towards the east. So the red one is the zenith, and this one is east, and this one is north. And again, you can see the light goes away. While I was in Zimbabwe, one of my colleagues at the Coast Guard Academy took a student to Zambia for the same eclipse. And her name was Jennifer Imbres. She's now a professor at the Coast Guard Academy. And she took this data, and you can see she's got a little bit different scale here, but here's where the first contact, so this is the beginning of the partial phase of the eclipse, and then as the eclipse progresses, the carbon dioxide level decreases. I'm not sure I understand that. I would have thought that as the light went away, the carbon dioxide would increase. But you don't need to understand everything. If you understand everything, then why do an experiment the next time? So we'll run this experiment another time and see if we can understand this a little bit better. Here's the maximum eclipse, and again, you can see the carbon dioxide takes some while to recover. In 2003, I went to Antarctica for the total eclipse there. Had a little bit of trouble setting my equipment up because we were only going to be in the eclipse zone in the path of totality for just a few minutes, and I wouldn't have time to set up my stuff and then take it down. So I set my thermochrons up outside of the path of totality, and you can see that as the sun set, that's one thing. Here's the time of the eclipse, so maximum eclipse is about halfway in between that. And you don't see much of a change. That's because we were not in the path of totality. We were several miles outside of the path. So this is actually one day. As soon as we landed on the airstrip, I set up my thermochrons. And you can see this, we were in the mess tent as I put my equipment together. And then as I took it outside, it got cold. And then as the sun set, the temperature dropped. And here the sun is it's almost on the horizon. And then as the sun rises, the temperature comes back. And so this is my last slide. It's a little bit unfortunate that there's no simple mathematical models for the way these micrometeorological measurements, how they change. It's not simple. So it's very difficult to compare theory to experiment. The theory is too difficult for most students to do the calculations. On the other hand, as I've been doing, you can discuss this qualitatively and make quite a bit of sense out of the data. Certainly, you can feel the temperature change during an eclipse, and so you can see the temperature change in the data as well. So I think I'll stop there, and I encourage all of you to do an experiment in 2012. Thank you.